Okay, this will be lesson 4 for unit 4 for pre-calculus. We're going to talk about some rational inequalities, and we're going to go to regular polynomial inequalities. Okay, the big thing you want to do is you want to move everything on from this side over to here. So if this is negative on this side, when it would move back over, it would then become positive. Okay, less than what's over here is 0. Just like with my rationals, I want to get a common denominator. So what I would need to do is multiply this side by x plus 1, multiply this side by x plus 1, multiply this side by x minus 6, multiply this by x minus 6. Okay? All right, I would distribute that. That'd be 4x plus 4. Take this as a positive 2. Now, if this is a minus, I would treat it like a negative 2. That's positive, so 2x minus 12, all over my common denominator. When I combine my like terms, I get 6x minus 8 over x minus 6x plus 1. Now I got greater than or equal to 0. Okay? Now, at this point, we want some key things. All right? We want our vertical asymptotes, and we want to solve the numerator. Okay? Well, my vertical asymptotes would be at 6, and x is equal to negative 1. If I solve that, okay, it'd be 6x equals 8. Divide by 6 would be x equals 4/3. Okay? Now, what I want to do, okay, is I'm going to put all those numbers on a number line. Okay? From smallest to biggest. So negative 1, 4/3, and 6. Okay? Now, what I want to do is I want to test to see where this is going to be greater than or equal to 0. Now, the idea behind that, greater than or equal to 0, okay, first of all, labeling this, okay, all right, if I've got this less than sign, all of these, I'm sorry, without the line underneath it, we'll have the open circle, okay, all right. Now, what greater than 0 means, that means we want a positive number. Less than 0 would mean we want a negative number, all right? Just a little idea, okay? The concept here is if I were to substitute on any, let's pick some random numbers. Let's say negative 10, let's say 0, let's say 5, and let's say 10. Why'd I pick those? Because those fall in those areas. And what we want to do is we want to test to see, is this number positive, is this number, in this case, we want positives, okay? So let's think about this. If I put in a negative 10 here, it doesn't really matter whether the exact number, it's whether it would be positive or negative. Well, 6 times a negative 10 would be negative 60, so I know this top part would be a negative, okay? If I put negative 10 in there, that would be a negative. If I put negative 10 in there, that would be a negative. Well, a negative times a negative would be a positive. A negative divided by a positive would be a negative. So this area is no good, okay? We want a positive number there, okay? So let's put in 0. Okay, if I put in 0 for that, 6 times 0 is 0, minus 8 would be a negative number. Okay, 0 minus that would also be a negative number. 0 plus 1 would be a positive number. A negative and a positive would be a negative now. A negative divided by a negative would be a positive result. So this is good. Okay, so that area is okay. All right, now let's put 5 in there. If I put 5 in there, 6 times 5 is 30. That's going to end up being a positive number up top. If I put 5 in there, that would be a negative. If I put 5 in there, it would be a positive. Negative and a positive would be a negative. Positive divided by a negative would be a negative. So this one's no good. Okay? Let's go to this last one for 10. Okay? So if I put 10 in there, that'd be 60. That's going to be a positive number. 10 right there, that would be a positive. 10 right there, that'd be a positive. This is easy. Positive over positive would give me a positive, so that's going to be good. Okay? So what my answer here would be to this question is negative 1 to 4/3 union 6 to infinity. Okay? All right? And that's how I get my answer. Okay? Let's do another one, maybe one a little bit differently, but somewhat the same. Okay? Let's say I got 3x squared plus 11x minus 4 all over x minus 2 less than or equal to 0. Okay? Now, I would try to factor this in this case, okay? And that's going to factor to, let's say 3x, x. This is going to be x plus 4 and x minus 1. Let's see. 4 times 3 is 12. Yep, that works there. All right, so I got this. Okay? All right, now, since I'm already reduced, there's nothing more I have to do there. My vertical asymptote here would be a 2. Okay? If I solve the numerator, the solutions for those, this one would be 1/3. Okay? All right? This one would be -4. Okay? So what I want to do, okay, is I want to list those. All right? Smallest one would be -4. Next smallest one would be 1/3. Next smallest one would be 2. All right, so let's pick some numbers. -5, let's pick 0, pick 1, pick 4. Okay? So what I want to do is I want to substitute these numbers in and look at whether they're positive or negative. Okay? So 3 times -5, that would be a negative number. This would also be a negative number, and this would be a negative number. Well, negative times a negative is a positive. Positive over negative would be negative. Now, since I want things less than or equal to 0, okay, that works. Now, as far as the dots go, okay, if you've got this symbol, this applies to the numerator solutions. Okay, so so this 1/3 and this -4 would be closed in dots. This one would be an open one. Why? Because the vertical asymptote will always produce an open circle, okay? That's something to understand, okay? All right? So I want a thing less than or equal to 0, which means I want a negative number. All right? So this ends up being negative, so that area is good. Okay, let's put 0 in. If I put 0 in for that, I would end up with a negative. If I put 0 in for that, I'd end up with a positive. The bottom would be a negative. Negative times positive would be negative. Negative over negative would be positive. Okay? So that's not what I want on that case. Okay? So I want to shade this here. Okay? Let's put in 1. 3 times 1 would be 3, minus 1 would be 2. That's going to be a positive number. Okay? This would also be a positive number. And this bottom one would be a negative number. Positive and positive is easy. Positive. That's going to be positive divided by negative, which is negative. That's what I want. There's where my answer is. Okay? Let's try 4. If I put 4 in there, that would be positive. If I put 4 in for there, that would be positive. And if I put 4 in for there, it would be positive. Very easy. This is going to be a positive result. Once again, I want something less than, so that would be my answer. Okay? So what would my answer be? I would be negative infinity to -4 union 1/3 to 2. Okay? All right? And what I'd like you guys to do is I'd like you guys to try these two on your own. Okay, so go ahead and pause your video. Go ahead and do those on your own. Okay, go ahead and unpause. So what I want to do is I want to move this back over to this side. So if it's positive on that side, when I would put this over, this is what I'd have. Okay? Let me put a little line under here. Okay? All right? So if I'm sorry, I messed up your answer there. All right, so what I want is a common denominator. This would be need x plus 6. This would just need x. Okay? So if I distribute that, that's going to be 3x plus 18. Now I treat this as a -1. -1 times x would be -x. All over my common denominator. Okay? All right? So, what I'd have is I combine those would be 2x plus 18 over x plus 6 and x greater than or equal to 0. Okay? All right? In this case, this is pretty easy to get the vertical asymptote. Vertical asymptote would be -6. this would be x equals 0. If I solve that part, that'll be 2x equaling negative 18, x equaling negative 9, okay? When I do the number line for that, okay, when I do the number line for that, I'd have negative 9, negative 6, and 0, all right? The negative 6 would have an open circle, and the 0 would have an open circle. This would have a closed circle, all right? Okay, so I gotta have some test points here. Negative 10, let's say negative 7, let's say negative 1, and let's say 1, okay? So what I wanna do is roughly substitute those in and see what I get. If I substitute a negative number, I think that's gonna be negative up top. That would be negative at the bottom. Negative right there. Negative, and the negative would be a positive. Okay, negative divided by negative would be negative. Since I want greater than or equal to 0, I know that one is no good. Okay, all right. All right, so that one's no good for an answer. Then I want to try negative 7. That would be negative 14. That ended up being a positive there. Negative 7 in there would be a negative. This would be a negative. That'd be positive over positive, which would be positive. That's good. Okay, all right. Take my negative 1. If I put that there, that would be positive. Put that there. That would be positive as well. And negative, positive over negative would give me a negative. It's not something I want there. This side, if I put 1 in, that'd be positive, positive, and positive. That's easy. It's just going to be a positive result is what I want. Okay, so my answer there would be negative 9, negative 6, open, union, 0 to infinity. Okay, all right. If I do this one, what I want to do is I want to factor. I got 5x, it'll be x minus 3, x minus 2. Okay, this is just x plus 1 greater than 0. Okay, all right. Now, since I've got this, that means they're all going to be open circles. So my vertical asymptote would be as negative 1. Okay, if I solve that, that would be 2/5. If I solve that, it would be 3. Okay, all right. The smallest there would be negative 1, 2/5, 3. Okay, all going to be open circles. Okay, now I wish I would have done the example in the video of this being less than so we could get a negative, but all right, you go ahead, we'll just work this out. All right, I may make that adjustment when we do it in class. All right, so test points, negative 2, let's say 0, let's say 1, let's say 4. All right, so if I put in negative, that'd be a negative there. If I put a negative, that'd be a negative there. That'd be a negative. That's going to be positive over negative, which is negative, which is not what we want. Okay, all right. If I put 0 in, that'd be negative. Negative. 0 plus 1 would be positive. So that would be a negative over a positive number. I'm sorry, positive over a positive number, which can be a positive, so that would be good. Okay, if I put 1 in, that'd be positive. 1 in there would be a negative. 1 there would be positive. That's going to be a negative over a positive, which is going to be a negative. Okay, put in 4. Okay, all right. 4 with that, okay, would be a positive number. All right, a positive as well. Positive on the bottom. Okay, and that's just going to be a positive, which is good. So that's here, and I want here. All right, so my answer to that question would be negative 1, 2/5, union 3 to infinity. Okay, and that's rations. Okay, all right. Okay, let's go to some regular. I want to do some regular linear inequality problems. Okay, all right. Let's say I got. We'll talk 3x cubed minus 1x squared minus 27x plus 9 less than 0, less than or equal to 0. And I want to talk about x cubed minus 2x squared minus 8x being less than 0. Okay? All right? Now, what you want to do is you want to factor this. Okay? Now, I'm going to give you the freedom to factor it any way you want. Okay? All right? Now, what you can do, all right, do a couple of things. You can find the solutions to this. So what I would do, we graphed 3x cubed minus 1x squared minus 27x plus 9, okay? All right, we learned, okay, that we can find the solutions. G solve root. One of the solutions is -3. One of the solutions is, that's going to be 1/3, and one of the solutions is 3, okay? Okay, if I make those into factors, it's going to be x plus 3, 3x minus 1, x minus 3, being less than or equal to 0. Now, you could have also found one of those and done synthetic division, okay? All right, there's a lot of different ways. Given the time of this lesson, we're going to just do it this way. Now, very similar to the last question, okay? What I want to do, okay, I don't have to worry about the vertical asymptotes, but I want to solve these, which I already got those solutions from here. That makes it easy, okay? So on a number line, I got -3 would be the smallest, then 1/3, and 3, okay? All of these would be filled in circles. I don't have to worry about the open circles, okay? All right, I got this little thing here, okay? All right, now, same concept. All right, -5, let's say 0, let's say 1, let's say 4. They're gonna be my test points for this, okay? So what I got here, if I put -5 into that, that would be a negative, okay? And then negative, all right? Well, that's gonna be a positive number, that's going to be a negative number, that's going to be a negative number. So that is good, that is what I wanted, okay? All right, because I have less than or equal to 0, I want a negative number. Let's put 0 in there. That'd be a positive, that would end up being a negative, and that would be a negative, okay? The negative times a negative creates the positive. That's going to be a positive result, so that is not what I want, okay? So we shaded here, okay? All right, let's test 1. I put that in there, that's 1, that's positive. Put 1 in there, that's positive. Put 1 in there, that's negative. That's going to be positive and a positive. That'll be a negative, so that is what I want as well. Okay, if I put 4 in there, that'd be positive. I put 4 in there, that'd be positive. Positive, I'm going to get a positive result, which is not what I want, okay? So what's my answer out of this? Negative infinity to -3, union, 1/3, 3. Okay, all right, you can go ahead and do that for this one. All right. So I got x to the 3rd minus 2x squared minus 8x. Draw. The roots are -2. All right, let's look at some of the other ones. 0. And 4. Okay, so as factors, those would be x plus 2, x minus 4 being greater than 0. Okay, all right. Now, on a number line, that's going to be -2, that's going to be 0, that's going to be 4 test points, -3, -1, 1, 5. Okay, once again, I'm testing, in this case, since I don't have this line underneath, all these would be open circles, okay? All right, now I want something that's going to be positive, okay? So if I put that first one in there, negative, negative, and negative, that'd be a positive times a negative, which would be a negative. That is not what I want. If I put -1 in there, that'd be positive, that'd be negative, be negative. Well, those two negatives will make a positive. That'll be a positive, so that is what I want, shaded in there. Okay, if I put a 1 in here, okay, that'd be a positive result, and a negative result. Positive times a negative is a negative, okay? That is not what I want, okay? And this last one, if I put 5 in there, positive, 5 in there, positive, 5 in there, positive, that's easy. That's going to be a positive, and that's what I want here. Okay, so my answer there is -2 to 0, union 4 to infinity. Okay, all curved brackets. Okay, all right. So let me give you guys 2 like that to do on your own. 2x cubed minus 3x squared minus 50x plus 75. Greater than or equal to 0. And then let's do 2x cubed plus 7x squared minus 15x less than 0. Okay? All right? That's 7 there, just so you know. Okay, so go ahead and pause your video. All right, go ahead and unpause. So what I would do on this first one is go 2x cubed minus 3x squared minus 50x plus 75. Draw, G-solve root. One root's at -5. One root's at 1.5. So 1.5 is 3/2. 3/2 is the factor is 2x minus 3. That is the factor is x plus 5. And I think there's one more. What's this other one at 5? So that's going to be x minus 5. All greater than or equal to 0. So I want a positive. Okay? Since I got that little line underneath, I know that my dots are filled in. Okay, -5 would be here. 3/2 would be here. This would be 5. Let's do -6. Let's do 1. Let's do 2. Let's do 7. Okay? I put that in there. Negative, negative, and negative. Be a positive times a negative, which would be a negative. It's not what I want. Okay, if I put 1 in there, positive, put 1 in there, negative, put 1 in there, negative. That's a positive times a positive. That's a positive. That's what I want right in there. Okay? If I put 2 in there, that's positive. 2 in there, it's positive. 2 in there, it's negative. Okay? So it's positive and a negative, which is a negative, not what I want. If I put 7 in there, positive, positive, and positive. All results positive, that's good. Okay, so my answer here is -5, 3/2, union 5, 2 infinity. Okay? All right, let's go ahead and do this one. So I got 2x cubed plus 7x squared minus 15x. Okay, one solution is -5, one solution is 0, and one solution is 1.5. Okay, all right. Now, since I got that, I'll have an open circle, 0, open, 1.5, open. Okay, it's factors, those would be x plus 5, x, and 2x minus 3. Okay, all being less than 0. So what am I looking for there? A negative. Okay, I'm looking for a negative, all right? So let's say -6, let's say -1, 1, and 2, okay? If I put that in, that'd be a negative number, negative, and negative, turns to a positive, negative, negative result, that's good, okay? If I put in a negative here, that would be a positive result, that'd be a negative result, that'd be a negative result, that's a positive times a positive, which would be a positive, not what I want, okay? All right, if I put 1 in there, that's a positive, 1 in there, it's a positive, 1 in there, that's a negative, that's a positive times a negative, which is a negative result, is what I want. And then 2, that's going to be positive, positive, and positive, obviously a positive result, so that's not what I want. Okay, so my answer is -infinity to -5, union 0 to 1.5. Okay, all right, so that is inequalities, linear, nonlinear inequalities, and rational inequalities.